So today we are starting the solving trig equations unit. Each day we're going to do a few problems just to kind of ease your way into this process. So I'm not going to cover all types today, but just enough to get you started. And each example is going to have 3 examples in it. The first one's going to be a really easy algebra-based problem, and then we'll add in the trig and see how that looks. Example 1, first equation, 7x plus 2 equals 23. Hopefully you get the concept, it's just algebra. Subtract 2, we get 7x equals 21. Divide by 7, x is 3. Conceptually speaking, that's what we're doing, but with trig. Let's see an actual trig problem. 2 cosine of x minus 1 is equal to 0. Your initial goal is to get the cosine of x by itself. So to do that, we need to move the 1 over. 2 cosine of x is equal to 1. Again, solve for the cosine. So we'll divide by 2 on both sides. Cosine of x is equal to 1/2. Once you get the trig function by itself, then you can focus on solving specifically for x. So let's see what this looks like. This one's fairly easy to do just using the unit circle, so that's how we're going to do it. When you're solving for x, you need to look at this and the question you're asking, what value of x makes it true, where cosine is equal to 1/2 on the unit circle? Where is cosine of x?
Is it 1/5?
Equal to 1/2. What'd you say?
It's not. 5 over 6. Is cosine?
Nope, you got the right.
Cosine y or x?
Yeah, you got it mixed up.
Pi over 3.
Yep, yep.
And,
In degrees. Hang on, we'll get there. Let me finish writing this down. On the unit circle. Where is cosine of x equal to 1/2 on the unit circle? Some of you are already seeing what I'm trying to give off here. We look on the unit circle where cosine is 1/2, and you guys have already pointed out, reminder, on these coordinate points, x, y, cosine is the x value and sine is the y value. So we're looking for the x values where it's 1/2. So the first one is at 60 degrees, and we'll always do degrees in this unit, so we'll never see radians. At 60 degrees, the majority of the time there's actually going to be 2 answers, so always look for a second answer. There's one other place where it's equal to 1/2.
300
Fourth quadrant, 300 degrees, it's also 1/2 in cosine x's place. So for our final answer, we say that x is equal to 60 degrees, comma, 300 degrees. As you can see, it's a bit more involved than just solving an equation. There's an extra step to it. Problem C. square root of 3 secant x plus 2 is equal to 0. Again, the first goal is just to solve for the trig function, in this case secant x. So we're going to get this by itself. Subtract 2 on both sides. Square root of 3 secant x is equal to negative 2. Divide by the square root of 3 on both sides. Secant x is equal to negative 2 over the square root of 3. If you're already thinking about how you have to rationalize the denominator because you can't have a radical on bottom, don't think that far in this unit. That's going to create more work for yourself than needed. All right, secant. A little more complicated to find that on the unit circle. So hopefully you're already seeing secant, that's the reciprocal of cosine. Let me remind you of something real quick. Well, you are welcome to replace that secant with one over cosine. You're going to have a little cross multiplying, a little more algebra before you get the cosine by itself. There is a quicker trick here to use. Reminder of our trig functions, sine, cosine, tangent. And their reciprocals, cosecant, secant, cotangent. And we remember their trig ratios. SOHCAHTOA, sine is O over H, cosine is A over H, tangent is O over A. Since these are the three reciprocals, it's the flipped versions of all of those trig ratios. So cosecant is H over O, secant is H over A, and cotangent is A over O. So we can easily change this to cosine by simply flipping the fraction. That's all we have to do. So my recommendation is flip the value that it's equal to. Don't flip the actual trig function. It will save you a bit of time. So this means that cosine of x is equal to rad 3 over 2. I'm going to put that negative on top for convenience. So again, we can just take the reciprocal of the right side instead of the left side. From here, we can use the unit circle to identify the x values. Negative rad 3 over 2, again, x's spot for cosine. So we should be looking on the left side of the graph here. Negative rad 3 over 2 at 150 degrees. That's the first answer. Again, always look for two answers. Negative rad 3 over 2, the other place it's negative rad 3 over 2 is at 210 degrees. Those are the values of x. Questions on this third problem? Okay. We're going to do another round of those, an easy problem followed by 2 trig problems, and then that'll be all for today. First problem, just algebra. X squared minus 3x is equal to 0. How do I go about solving that? What was it? GCF, good. We have a factoring problem here, and specifically it's a GCF, so brush up on your factoring. You're going to be using it on this section. GCF here, they both have an x, so I'll pull out x. out of both of these. X comes out, it doesn't disappear. What's left goes inside. X squared over x, that just leaves an x. Minus 3, these x's cancel, equals 0. How do I solve from here? What's the procedure? Not a guess? Okay. Split and solve. You make two separate equations. X equals 0, x minus 3 equals 0. Split them up. X equals 0 is already solved. There's nothing else to do here, so I'll unbox it. X minus 3, we just add 3 to both sides. X is 3. You can box them separately, or you can make a comma separated list. Put them as one answer. Either is correct. Now let's do one of those with trig involved. Two sine squared x plus sine of x is equal to 0. First off, if you're struggling to see the algebra in the problem because of the trig functions, you are always more than welcome to rewrite this with just x's. So this would be 2x squared plus x equals 0. Just to kind of give you an idea of where to proceed, just use that method carefully. Some students just straight up solve for x and forget to put the trig functions back in and continue solving from there. So it's helpful, but again, use it carefully. All right, we've got sine in both of these terms here. So this is another GCF problem. We can take out a sine out of both of these. Sine comes out. First term, we have sine squared over sine, so that's going to leave a single sine left. That 2 just hangs out there. It doesn't cancel at all. So this becomes 2 sine of x plus sines cancel, so this is just 1. Same thing here. We can just split these up into two separate problems and solve. So we have sine of x is equal to 0. 2 sine of x plus 1 is equal to 0. This sine of x equals 0 is solved for now, but we're not done. We'll have to go back and actually find those x values. So I'm going to keep that as it is for the moment. I'll go ahead and solve the 2 sine x plus 1 equals 0. We'll subtract 1 on both sides. 2 sine of x is equal to negative 1. Divide by 2. Sine of x is equal to negative 1/2. From here, I have to use the unit circle to figure out those values. For each x value, you search for 2 angles on the unit circle. So I am hunting for 4 total answers. Let's start with the 0. Reminder, sine is in y's position, so now I'm paying attention to the y value of these coordinates. Looking for where y is 0. That's on the x-axis at 0 degrees and 180 degrees. So for our first equation, x is equal to 0 degrees and 180 degrees. That's 2 of my answers. Now I'm going to look for these answers. Now I'm looking for where y is negative 1/2. It's going to be on the bottom half of the unit circle. Negative 1/2 here at 210 degrees. And the other one, where am I at here? There we are. 330. So 210 and 330, those are my two values. So there are all four answers to this equation. Reminder, you won't always get 4, but you should always look for 4, 2 for each x value. Questions on this problem before we do our last one? Okay. Last one. Tangent squared x minus tangent of x is equal to 0. Same idea here. We have a GCF. Tangent can be pulled out of both of those. So we bring out a tangent. Tangent squared over tangent, that's just going to get rid of one of the tangents on top. Tangent of x, yes?
What about that negative sign? Where does that come in?
I'm just going to bring it down for now.
Oh, okay.
Minus. And then tangent over tangent, that cancels and just becomes 1. This is what we're looking at right now. We can split it up. Tangent of x is equal to 0. Tangent of x minus 1 is equal to 0. We'll solve both of those. Left equation's already solved for the time being. Right equation, we'll just have to add 1. Tangent of x is equal to 1. All right. Tangent gets a little more complicated. You can't just, with experience you can, but right now where you guys are at, most of you can't just eyeball tangent on the unit circle, especially since it's been a minute since you've used it. So just a quick refresher. What relationship between sine and cosine gives us tangent? Y over x, sine over cosine, right? That's what we just spent time on. Tangent is equal to sine over cosine, which is y divided by x. So you're not just looking at one number or the other, you're looking at both. Again, with experience, this becomes easier, and you can eyeball it on the circle, but that takes experience. So I'll do it with just the unit circle, the manual way, if you will, on the first one, 0. So tangent here is sine over cosine. And if we want 0, that's where we have 0 over 1. So that will give us the point 1, 0, which is 0 degrees on the unit circle. Now this works with one other point on the unit circle. Does anyone know what that is? That's the same thing. A different one. Yes. We can also have 0 over negative 1, and we'll still get 0. So that point is at 180. So these are the two x values that satisfy tangent of x equals 0. That's one way to go about this problem. The other way is using the calculator. The calculator does make it a bit easier, but there is a drawback to it, so I will show you that. And you could have done this problem, the first one, with the calculator as well if you preferred. So if you use the calculator, we talked about this back in semester 1 between Thanksgiving and Christmas. We spent time on this. Solving tangent of x equals 1 manually for x. That's x equals inverse tangent of 1. If you felt like you really missed out on this lesson last semester, I am sorry. There are some pieces to be picked up, that's for sure. Inverse tangent of 1, before you type this in, make sure your calculator is in degrees. If it's in radians, you will get a different answer from me. A quick check, if you have this calculator, it will say at the top degrees here. If there is a radian written there instead of degree, you need to fix that. So under mode, depending on your calculator, it's the third or fourth option down. Degrees should be highlighted. If it's not, hover over it and hit enter to darken it. Again, if you have this calculator, you'll know when it's fixed because it'll say it at the top. Any other questions on changing the mode before we do the problem?
Not on the mode, but how did you know which one you had?
To put 1 in it?
Yeah.
It's of the right side. So you invert both sides. That gets rid of it on x. And then the right side, the number that was already there, goes in the parentheses. Yeah. So I'm going to type this in. Second tangent, to get that inverse on the screen. If you manually type in tangent to the negative first power, it will not work. That's different. 1. And you'll get 45. So x equals 45 degrees. Reminder, we always look for 2 answers. So the calculator will give you half of that. The calculator will never ever give you both answers. It will always default to one of them. You have to go search for the second answer. So let's do a major flashback to last semester. How to find the second answer. First thing I'm going to do is graph the angle I've already found, 45 degrees. That's in the first quadrant. You can look at your unit circle if you need help with that. So this is 45 degrees. That's our angle of rotation, which we called theta. And then in order to do what I'm about to do, you need to know alpha. Alpha is the distance from the x-axis to that angle of rotation. 45 degrees, that's our alpha. Since we're in quadrant 1, alpha and theta are exactly the same measure. There was an acronym to help you remember where the functions were positive and negative for the 4 quadrants. Does anyone remember that acronym? Yes. Yes. All, S for students represents sine, take as in tangent, and then calculus for cosine. I know most of us do all students take calculus. You might have learned all students think college, depends on your teacher. But this tells you where the functions specifically are positive. So in this quadrant, remember our problem is where tangent equals 1. In the first quadrant, this is where tangent is positive 1. There's one other quadrant where tangent is positive 1, and it's the T quadrant. This is where tangent is positive. The other 2 quadrants is where tangent is negative 1. So it's going to be positive in the all quadrant and in the tangent quadrant. So depending on the sign of your answer will determine which quadrant you're going to be picking. So since I have a positive, I need the other positive quadrant. So I'm going to copy this drawing over here. This angle, the black angle I just drew, that's the angle I'm trying to find. So let's draw in the alpha. Again, alpha is the distance from the x-axis to the angle of rotation. And it's still 45 degrees. It's going to be the same for this quadrant. And it's helpful to remember that this is 180 degrees over here, and we want to find the value of this angle right here. So we just do 180 plus the 45 to get this number here, which you can cheat and look at the unit circle if you know what you're looking for. That's the middle angle right here. 180 plus 45 lands you at 225 degrees. There is your other value of x. So putting all of our answers together, we got 0 and 180 from the first problem that I solved over here. And then I just found these two. I could have put them as one list if I wanted to, or two separate, didn't matter.